So let's get started. We're going to be talking about mostly surveillance systems here with a little bit of annunciation and communication at the end. So let's get right into it. My experience in physical security has pretty much always been on the surveillance side. So I'm hoping I can make this interesting at least and maybe get through it on time. So the core aspect of, let's start with the first bullet point, the core aspect of surveillance and any component of physical security. There are three parts. Remember the 4Ds? What we're going to narrow down here is more deterrence, detection, and response. That's what we're going to be talking about today. When we're talking about surveillance, the primary function of surveillance should be security. If there's a secondary mode, say it's a business mode is for doing retail surveillance or retail people counting, which can be done with cameras or something like that, the primary goal should always be security with surveillance systems. And this is very important. Application dictates equipment, not the other way around. Don't let a vendor come in and try and sell you on equipment because it's the best there is or whatever. It's the application that should dictate the equipment, not the other way around. And you regularly need to review the plan you come up with finally, because things change. You know, even interior cameras, window shades may go up to affect lighting that was okay before. Things may move around, the building may move, the rooms may change. So it needs constant review. So the uses of video surveillance is, of course, real-time monitoring, the actual surveillance part. It could be manual or automated based on an alert or an alarm input. The next part, of course, is assessment, verification of current or recent events. Think of video verification. If an alarm is received from a sensor in the field, your video should be able to give you verification of something is going on that you don't want to happen, or nothing is happening. It could be a false alarm or a nuisance alarm, more than likely. Forensics, that is post-recording. After the video has been recorded, of course, you have your evidence of what happened based on date and time. You can go back and search for an event. You can even search for a particular analytic event if you have that capability. And of course, risk mitigation, using analytics to trigger proactive alerts. Analytics, for instance, there's lots of good loitering analytics these days that can go on the camera themselves, that can go on the edge, and that can detect loitering and alert the Security Operations Center, the SOC. The main elements of a video security system, we're going to be talking about all this down the road, but the field of view is what the lens can see, what goes through the lens. That is the angle of view or field of view. It could be something like 180 degrees for a wide angle panoramic camera, 90 degrees, 50 degrees, whatever you choose, or whatever can be adjusted into the lens itself. The scene refers to the specific location to be observed. It could be a northwest corner, southwest corner, parking lot A, B, C, D, whatever. That is the scene that you're going to have. The lens, clarity, focal length, iris, something we don't have to deal a lot with these days. A lot of it is so automatic and it works quite well. And one preface I forgot to mention is that we're going to be talking about what ASIS and the protection of assets thinks about video surveillance. So it's their game, it's them. There's some things here that I may disagree with, and you might too, but just remember, we're talking to the exam itself and what the POA says. And that'll be evident later on when I discuss a little in more detail. The camera, of course, itself, that converts an optical image through the lens to an electronic signal that can be used to be recorded or whatever you need to do with it. The transmission of the transmission media can be coaxial cable if it's an older system, unshielded twisted pair or shielded twisted pair, STP, UTP, fiber, or RF or wireless solutions. And the workstations themselves, those are the client PCs and monitors which connect to a server, a VMS server, for operators to use and to view the video and control playback. And then, of course, the recording equipment itself, it can be a digital video recorder, a network video recorder, or a video management server. So we're going to be talking more about this in the upcoming slides. So from CCTV to VSS, in them old days, back when analog was the only way to go, we're shifting from an analog system. Of course, we've already shifted to network digital systems. That enables us to have higher resolutions, high definition megapixel. We were limited with analog systems to a specific resolution based on the video system in use, NTSC or PAL or CCAM. But that was the limitation, and it wasn't a very high resolution image at that time. Integration, alarms must queue video fast enough. So when an alarm occurs, it should be able to start recording that video as quickly as it can. It should be a matter of milliseconds. But no matter what, whether using analog CCTV or a digital network video system, the theory and application is basically the same in terms of lenses and dealing with fields of view and resolution. So that has not changed. So for functional requirements, start as always with a purpose. We mentioned a few weeks ago that you have to define what you're trying to protect. What is your asset? It's exactly the same with video surveillance. Why do you need the system? What is your risk? And what do you need to protect against? What is your asset? Stakeholders, get stakeholders involved. These days, you would definitely get maybe HR, you would get the security manager, and definitely get the network administrator clued in, because he wants to know what's going on his network, I'm sure. What must each camera see? What are the targets? Are they individual people? Is it vehicles? Is it just general surveillance? The requirements. Proactive alerts, real-time view and recording, and each part of the system should have functional requirements written for them, including the cameras and the video management system. And we'll talk a little bit more about that. So the target can be people, vehicles, packages, perimeters. Activity could be assault, vandalism, trespass, robbery, or object left behind. And operational need defines the view. So we're going to talk more about this, but it's actual identification of a person versus direction of travel, which means identify an individual, what direction he left the building or the parking lot or whatever. And the camera type trade-off, a fixed, reliable view versus a pan-tilt zoom camera, which gives you good coverage, but the only problem with the pan-tilt zoom is as you're facing northwest, maybe something is happening southeast. You don't know unless you're covered for that area too. But the PTZ does have many advantages in that you've usually got a nice long zoom lens on it that can enable you to see close-ups in good detail. 4 reasons to have a video security system. See what's happening, to obtain live visual information about something that's happening. See what happened. This is what recorded. This is your forensic side. What happened yesterday at 2 a.m. You can go back and look. Deter undesirable activity. Yes, cameras are a deterrent. They can, if they're well installed and well covered, they look professionally installed. That can be a very good deterrent. And analytics. There's all sorts of analytics we'll talk about in subsequent slides, but one of the main uses of analytics is to assist the operator, take the load off the operator, make it easier for them and their SOC to see what's happening and to have alarms pop up based on actual analytic events. So design steps for a video security system. As always, start with a written message on what is the purpose of the proposed video surveillance system. Is it going to be a single location? Is it going to be multiple campuses? Is there going to be any need for non-security use, such as traffic or product flow monitoring? Definitely, as I said, engage stakeholders at this point. One of the most important people these days, I find, is the network administrator, the network admin. Be his friend if you can, because he can make or break everything depending on what he wants to do with his network. Write a purpose for each individual camera. Get a spreadsheet, write down what the camera is looking at, what direction it's pointing in, and what the main purpose is. Define the areas to be viewed by each camera. Number 3, that specifies things like the mounting height. The good idea to label the camera too, obviously, the on-screen display. Typically, you can label cameras through the video management system or the camera itself, such as northeast corner. So the operator always knows, he looks at the camera and he always knows exactly where in the campus he's looking at. And finally, number 4, choose a camera based on sensitivity, resolution, and features. We're going to cover that in subsequent slides. And one of the things I can't understate is, whenever possible, conduct live on-site demonstrations to confirm performance. If you're working with a vendor or with a manufacturer, they usually have the ability to come on site, and they're more than willing to do that to test out their wares at night, during the day, and put it through its paces, so you can actually see what will be the end result of pushing the camera to its limitation. Okay, the order of priorities. And again, I agree with this, but this is, remember, this is the ASIS's opinion and the POA. So the number 1 priority for selecting a camera is its sensitivity. And that's its ability to see in low light conditions and see well in low light conditions. It also includes infrared. Most cameras can see into the infrared region with the removal of a motorized cut filter that lifts up to allow infrared light through the lens. And that enables infrared illumination from a source, either built into the camera or an external IR illuminator. Second is resolution. There's all sorts of, the resolution wars seems to have slowed down a little bit. Typically now we're settling down at like 4K, even 1080p cameras, 2 megapixel and 8 megapixel cameras are getting quite common these days. And the 2 megapixel, the 1080p, is actually still very useful for many applications if you're not shooting too far. Number 3 in the priority would be features. That will be things like analytics capability, wide dynamic range, things like that. And this is a little bit of a throwback to the days when the lens and the camera were sold separately, but you should always think of the camera before the lens. So think of its sensitivity, resolution, and features before you choose the angle of view or the field of view. But these days, the lenses are typically integrated. But as I said, and I'm going to keep repeating this, this is ASIS POA talking. Okay, identification views. We're going to expand on this again. Subject identification. Beyond a doubt, that is Bill, that is Harry, that is John, without a doubt. That is subject identification. That is basically facial ID. Action identification. Capture the act. What was the recording trigger? What happened? And scene identification. Know exactly where the scene is. All the operators, typically they'd be looking at a multi-monitor array on the SoC. All the operators should be very familiar with what the camera is looking at. Again, I'm stressing again, labeling the cameras appropriately on the on-screen display is very important. So let's go back in time to analog system components. And yes, this is still in the POA. So back in the day, when it was all analog and a coaxial cable, you basically had the camera, the transmission cable, and the monitor. That was a usable for surveillance system without recording, of course, but that would display an image at the very least. Other parts would be PTZ units and controllers. They were expensive back then, and they needed separate controllers and a separate cable run in many cases for the pan-tilt zoom motors. I think Pelco came up with a decent system called a coaxitron, which was basically sending the pan-tilt zoom information up the same coax, which was a nice way to do it, to reduce cabling. But typically many manufacturers use serial cabling for their PTZ control. Switchers, we had sequential switchers, which were very simple. They just triggered between cameras in sequence, and the time between each sequence was set by you. A quad would give you a 2x2 split view on the monitor. A multiplexer typically would put multiple inputs on one output simultaneously. So then you could choose more higher defined groupings, such as 3x3 or 4x4 picture grouping. And a matrix switcher was simply a device that allowed multiple video inputs to be switched and routed to multiple outputs, including recording and displays. Amplifiers, you should probably avoid them if you have a noisy video signal. Back in the day, some people thought, let's amplify it. No, if it's noisy going in, it's just be double noisy coming out. You can't improve it with amplification. It's probably something with your cabling or some other factor. And analog recorders. I remember VHS recorders for time-lapse recorders, and I don't think there's many of them around now, but the analog recorders would be any tape or even hard drive with a digital video recorder. Now, back to the 21st century, network video components. You would have IP cameras, PoE switches, and storage. PoE is power over Ethernet. It's just a way to power the camera using the same network cable that transmits data. There's various grades. There's class 1, class 2, 15 watts, 25 watts, and so on. There's even a PoE++ now that can send 90 watts to the power device. So that is pretty amazing. And it's actually used for lighting as well. Office lighting can be PoE these days, and smart as well. And storage would be on a network video recorder, which is typically an appliance with a network connection and all the software built in, or a video management system, which can run on a custom server or a manufacturer-specified server. Transport is typically on Ethernet cabling, unshielded twisted pair, or even shielded twisted pair STP. It can be fiber, radio frequency. And just remember, no matter what Ethernet you're using, and we'll talk a bit about category types in future slide, just remember there's a 100-meter, 328-foot rule for UTP and SDP. You cannot run more than that. And when before I retired, I came across many instances where cable runs were 400 feet, 500 feet, and they just thought they'd take a chance to see if they could get it to work. But I guarantee it won't be a reliable solution. You've got to stick to that 100-meter rule. More components, encoders, that would take in any existing analog cameras and encode them and put them on your network and be able to record them on your updated recording system. Multiplexers, digital video recorders, and servers and NVRs, of course. And repeaters and optical fiber basically can extend the distance. You can actually use coaxial cable via converters. So there's an encoder at one end of the coax and a decoder at the other end, and you can run standard TCP/IP over a coaxial cable for sometimes over 1,000 foot. And what's good about this is if you have an existing heavy infrastructure of coax and you're in a protected building where you don't want to rip everything out, you can utilize your existing coax using these converters. And they're quite a handy solution in many cases. System design principles. Keep perspective. Simple beats complex. Very good advice. A simple solution beats complexity every time. Again, we're stressing this. Let the application pick the equipment. Whatever the application is, whether it's a school entrance, whether it's a retail environment or a factory, let the application pick the equipment. And design generically. You can usually use the same model camera throughout an installation unless there's something specialized needed, like a pan tilt zoom or a much longer lens. Design the best option first, then size up the budget afterwards. See what you can do with the best option. And deploy in phases. Go through the phases 1, 2, 3, 4. That enables you to leave room for things like expandability. Phases are a very good way to do any kind of work because you can keep an eye on what's going on in smaller increments instead of having one huge dump of cameras and equipment all over the place. So it's a good idea to do phased deployments. So the 4 design steps, right, overall purpose, identify uses and stakeholders, write the purpose of the camera in each system, do that spreadsheet, come up with it, and write what it's for, what it needs to see, and what the resolution needs to be, that sort of thing. Define camera placement and view with plans. And plans aren't as scary as you think. I mean, it doesn't need AutoCAD or anything like that, or CAD drawings. Many manufacturers, we'll discuss later, have their own design solutions online, on free solutions that enable you to do camera angles and storage calculations too. And then choose your camera style based on the parameters that we discussed: sensitivity, resolution, and features. And definitely this is when you should bring in your manufacturer or vendor to do on-site demonstrations to see how the camera performs. Okay, that's step 4, and this is more on step 4, the type of camera. So we discussed this: sensitivity, light levels, variability, spectra, can it see IR, resolution, what kind of detail do you need, features, wide dynamic range, things like autofocus. Again, this is from the POA. They typically all have the ability to focus remotely at this point. Shuttering, less of an issue these days, and backlight tools. Anything where you have a strong backlight, you have auto iris, masking feature, electronic iris, and of course WDR, wide dynamic range, which is the ability of the camera to bring in very bright scenes and not lose detail in the very dark scenes. Conversely, you want to bring up the gain to see the dark scene, you won't wash out the bright scene. So it balances everything into a much more usable image. And WDR these days is very, very good. More on choose a camera. Thinking environmental. The housing is very important, of course. Does that housing need heaters and fans for winter and summer use? Sun shields to keep sun glare out of the lens, very important. Mounting. Most manufacturers have good mounting accessories for every eventuality. Think of the mounting height. You've got angles, swing arms, you've got pole mounts, wall mounts, all sorts of different mounting options. Power, PoE versus local. So you can use PoE in many cases, except if it's a very, very heavy duty motorized PTZ with infrared and lots of heating built in. Then you may need local power for that. And that can be 24 volts AC, but typically you need a local 110 volt source. And the transport method, whether it's coax, UTP, fiber, wireless. If you're using wireless, plan on using some sort of encryption. It's good advice to do that. And that is actually a very good point. So let's talk a little bit. Now, everyone has their own ideas on this, and every manufacturer will tell you different ideas. But this, again, is ASIS POA. This is what they say. So you've got identification view, you've got a description of what you might see, and you've got pixels per foot, which is something they talk about in the POA as well. It basically means how many pixels can you see on the image per foot of real estate. My head, what, 10 inches maybe? Let's call it 12 inches just to make it a foot. That means if you were looking at me on a camera, you would see 5 pixels across my face. That is not enough to see anything. That is nothing at all. Monitoring, traffic flow, no serious detail on blow up, 7 pixels per foot. Again, not enough across my face. 7 pixels is meaningless. Detection, that should enable you to see person-sized targets detected, not identified. And that will be 11 pixels. You basically have a pixel an inch at that point, which is still not very much. Observation, in that case, clothing and colors are distinctive, but again, limited detail, 18 pixels. Think of that across my face. Recognition, it's high accuracy for known individuals. An unknown, you may have a problem, but a known individual, you have a good shot and good blow up. All that means is you're digitally zooming in on the image captured. 35 pixels, now we're getting somewhere, right? That's almost believable that you could see some detail on my face. Subject identification, the identity is beyond doubt. For that, you would need 46 pixels per foot. And think of that across my face again, 46 pixels. License plates. Yes, license plate recognition is a big thing these days. And for that, you need to get 70 pixels per foot. Depending on the state you're in, the license plate could typically be 12 inches wide, maybe a little less. So 70 pixels across that license plate is actually good. That's very good. And it will be great on my face too. And finally, the most detailed you can get would be facial recognition. So that requires 88 pixels across my face, which I think you can understand by imagining that would give you a good idea of who I am. Now, numbers to remember. Typically, they're probably going to ask a question on things like facial recognition. So that is the highest. That is 88 pixels. Some manufacturers will tell you 80. Some will tell you a little more or less. But again, this is the ASIS POA. Recognition's 35, subject ID is 46. These numbers, try to keep them in your head. The lower numbers I wouldn't worry about too much. There's usually not any questions on that. But where you will find questions is that on anything from 35 pixels per foot and up. They may ask you what is the ideal resolution for facial recognition. Of course, that's the highest, 88. So try to kind of just get an idea of that in your head. Okay, network cabling snapshot. Let's move on to network cabling. So you've got UTP and STP categories, Cat5e, Cat6, Cat6a, and Cat7. They all have different bandwidth capabilities. Typical 6, 6A, and 7 are all at 10 gigabits per second bandwidth. Cat5e, don't see that much anymore. That's 1 gig. But every installation I've seen these days starts at the very least at 6A and should be. That should be the specified cable. And that, again, you've got your 100 meter limitation. No matter how good the cable is, you still should never go over 100 meters. For long runs, you can consider fiber optic. If it's going to be shorter distance, you can use multi-mode fiber. For longer distances, could be thousands of feet and more, you would use single mode. Very good solution because it's got very high electromagnetic interference capabilities. And coax can run 1,200 feet or so with converters. But I wouldn't specify coax as this transport media. That would typically be if there's already coax installed and a camera way out somewhere that you can't run a new cable to, then you can definitely utilize the same coax. Match media to network type and camera load, very important. So if you have 25, 20 megapixel cameras, make sure you are using Cat6a and your network capability is such that it can handle that. Talk a little bit about lens field of view. A lot of this goes way back to the analog days, but again, I'll say it again, it is in the POA. So you would match the format size, the sensor format size, which typically is 1/2 inch these days, but back in the day, it seemed like sensors were getting smaller. They went down to a 1/4 inch, but then they went back up again when they realized the 1/4 inch didn't really give us that good resolution. I'm sorry, not resolution, sensitivity, because it's a physically smaller area. So it's coming back up, and typically 1/2 inch is typical these days, or even they might be bigger for special cameras, up to 1 inch sensors. So in the old days, we had a camera, then we had to buy a lens for it. So you had to match the format size. If you had a 1/3 inch camera, you had to have a 1/3 inch lens. Otherwise, you get vignetting, or the lens angle will be totally messed up. Use the true camera to subject distance. Get a measuring wheel, whatever you need to do when you're doing a site survey. Make sure that it's capable of doing that. And field of view drives pixel density and ID level. So a tight field of view will give you a high pixel density, and a wide field of view will give you less pixel density. And lens types, we've got fixed, varifocal, motorized zoom. We'll talk about those. Now, talking a little bit about manufacturer solutions. Hanwha has their WiseNet Toolbox Plus. AXIS has their Site Designer. These are two examples. I've used Site Designer quite a lot, and it's actually a very good tool. I'm not disparaging Hanwha in any way. I just haven't used their tool. But both of them are capable of finding a model number in their portfolio, and then it would give you calculations based on that model. It would give you your pixel density. It would give you your resolution expected and a good idea of your field of view. Sometimes you'll see this Dory here, and AXIS use it as well. I just don't see it on this slide, but DORI stands for detection, observation, recognition, and identification. There won't be a question on that. Don't worry about that. It's just for your own background knowledge. So those lines will be drawn, like identification will be closer to the camera and detection will be way out here. They typically have lines drawn in their field of view cone. Both these applications will do storage calculations for you. So if you put in all the various cameras you need, not only will it draw a map for you, or you actually import a map and then you place the cameras on there, it will also do storage calculations based on third-party video management systems and their own video management system. So it'll tell you how many terabytes you need based on your storage requirements and everything else. The AXIS one is interesting. You import a floor plan and you have to scale the floor plan to the cameras, of course. There's a tool to do that. But if you're taking in a Google map, this uses the Google Map API, so it automatically scales a Google map if you bring it in. This Hanwha WiseNet toolbox, I'm not sure about, but I imagine you can do the same thing. But it's a very good tool. You should check them both out if you get a chance. Just Google WiseNet Toolbox Plus and AXIS Site Designer, you'll find, and they're free to use. I think you have to sign up as a partner or whatever, but they're free to use. So, video surveillance cameras types, analog CCD, don't see much of that anymore. There used to be dedicated black and white cameras that did have better sensitivity because they didn't have the color filter in front. Hybrids exist, yes. Again, this is the POA. IP cameras, I don't see too many standard definition IP cameras anymore, but they start at 1080p usually. So HD, megapixel, and of course, smart edge analytics embedded. They've got very powerful analytics capabilities these days. They've increased the processing power quite a lot in modern IP cameras. Infrared assisted, it needs an IR source, of course. It has to be able to see into the infrared zone. A thermal camera, that is a very useful perimeter protection tool because it sees temperature contrast, not a light contrast, but temperature contrast. So that enables you to trigger an alert based on heat moving, which is a very valuable tool to have. And of course, day-night camera, typically they mostly are these days, unless it's a less expensive fixed camera, but they typically have a removable motorized IR cut filter. So types of lenses. You have wide angle, and we'll go into various fields of view in the next slide. You have a standard telephoto zoom. I would bunch these together. Varifocal gives you a small zoom range, so you can get a little fudge factor built into your camera installation and zoom in a little bit more, a little bit less. Iris is fixed, manual, or auto. Video versus DC. I haven't heard of this for a long time, but basically, back in the day, in the analog cameras, a video iris lens took a video output from the camera through the connector to the lens, and the lens adjusted based on the video signal strength. DC control put the processing for that in the camera, and the DC voltage output from the connector to control it. I can guarantee you probably won't see much of this. Mounts and format, C versus CS, that were two different screw mounts. You couldn't use one over the other because they had different distance to the imager. So you could get vignetting or you could get a very poor lens fit. And of course, color and R corrected glass were required. That's typically a requirement these days for most cameras. If I'm going too fast, if you want me to slow down, please do. I'm just trying to get through as much of this as I can. So the lens types and the respective distance range and field of view. So a wide angle lens, typically 90 degrees plus, that gives you a nice corner shot. The best distance range would be about 0 to 15 feet, so for close range. A standard lens is typically about 50 degrees field of view. So imagine 90 approximately divided by 2. That would give you 15 to 50 foot in terms of viewing distance. And this also gives you a natural perspective. It's wide angle can distort the image, make things wider. This gives you a natural perspective. Telephoto, it can be greater than 50 feet. Field of view could be 20 degrees depending on how far you're zoomed in. It does a great job on distant objects, but like I said, it does have a very narrow field of view. And the same can be said of a zoom lens. The field of view is variable. Some of the new PTZ cameras go all the way down to a 2.8 degrees field of view on full tele. that's hard to track something at that angle. Everything shifts so quickly. But it's very good for crowds, for instance, at a stadium, seeing people and getting a good close-up. And a varifocal lens, that's very common these days. It typically is a lens that's got a very limited variable range, maybe from 3 to 9 millimeters, which is like maybe 40 to 90 degrees or something. And it gives you the ability just to do adjustments. When you install the camera, maybe you find it's a little wide, you can adjust the varifocal lens to get what you want. It was never meant to be continually moved back and forth. You can move it from typically the camera interface, but it was never meant to be a zoom lens solution. So camera formats, pixel density, and compression. So the sensor and the format affects the field of view and the lens choices. Yes. Task-based pixel density. So the goal, the system goal should define your pixel density. Do you want to see people's faces? Are you just looking for a general overview of people coming in the building and then catching them later with a higher resolution camera? You can do that, because one thing that pixel density is, it can be backed up by lower density cameras just for doing overall wide scenes and then tracking them with the higher density camera. Your resolution is always limited by the weakest link in your system chain. If your compression is set too high or set incorrectly, even if you have data problems with your network, or a switch may be bad where it's not transferring data at the right bit rate, that can affect your recording quality too. And use modern codecs. The standard these days is H.265. It took a long time to get from H.264, but typically everyone is now standardized, it seems, on H.265. It does a very good job on compressing the video down while maintaining quality and giving you very good options for your storage and bandwidth. Okay, controlling software nodes, basically your video management system would be typically on a server, a central server somewhere, and that's where all your live playback alarms and permissions will be processed through that central VMS server. Design nodes. So a node, think of a high-rise building with a backbone going up the building to the various floors. Each floor would have its own node. So that will be a node, maybe 10 cameras on one node, 5 on the other, 20 on the next, that sort of thing. So that would help you define your, that all has to be added up to your overall bandwidth. And also, one thing also to remember with PoE is also, PoE is now part of the equation. And there probably won't be a question on this, but if you have 100 cameras, each drawing 15 watts, you got to make sure that you have enough switches to enable to supply that power. So you don't want power to drop out because of a too much of a heavy load. The alarm input output can be at the edge or the head end, the edge being the camera itself, or the head end. Or it could also be a door contact for that matter as well. And plan for multi-site viewing if you want to have a multi-campus system. Plan for mobile access, and plan for role-based access. So that would be at the client. The client PC, that is the client computer, you would assign roles based on responsibility. So an admin would have privileges to do whatever they need to do. A viewer or an operator would have certain privileges that they can't do. Some might have very basic, where they can't even swing a PTZ camera, but they can at least view the video. So role-based access is important. Little board and recording systems and services. The DVR is analog. NVR can be IP or hybrid, and a server VMS architecture is always. I always think of NVR as a kind of an appliance. A server with a VMS, of course, could be a rack-mounted server with running the VMS. The storage math, that will be frames per second, resolution, compression, and motion. Those variables would give you your storage. Frames per second, typically people, if there's a requirement for 30, typically casinos have a requirement for 30 frames per second higher frame rate. Most general is maybe 15 to 20. It's usually good enough for most applications. Resolution depends on what you're looking at. Compression, again, H.265 typically, and the amount of motion you have would determine that. And also, you would be sure that your storage can fit into your storage retention, which I've seen typical numbers like 30 days, but if it's retail, it might be a year or so, 6 months to a year, to allow for any litigation or slip and falls. The applications I mentioned, Site Designer, Access Site Designer, and the Hanwha product, they will do all this for you, so there's no need to sweat it. Cloud managed video, getting very popular. Basically, someone else takes the onus to record your video in the cloud. It's really good for some people who maybe have many sites. Think of a restaurant chain or coin-operated laundries. If you have 10 or 12 of those in a city, it's a good idea to have everything cloud managed, although it is a subscription service, so can get expensive. And of course, when you're done, well, one thing you should check is your export, your video export. So typically the files that are stored on your VMS server or your NVR, it's a proprietary format in most cases. That has to be converted into something that normal people can see, such as an AVI file or an MPEG, MP4 file, something like that, so they can view it on the computer. And that should include also any watermarking to stop any tampering, and it should also comply with any chain of custody that you have. Video assessment considerations. It should integrate with your intrusion detection system. We mentioned that last week. You should probably design in terms of zones and priorities and triggers. The layout, you should clear zones. Like we said with sensors last week, make sure you have a clear zone around your fence line and leading up to your fence line, because that is the best thing you can do to get good video at those points. Uniform spacing of lighting, and lighting should be adequate for wherever you're shooting at. If it is a perimeter, there should be adequate lighting there. One fixed camera per exterior zone. If you think in terms of a defined zone that you actually define yourself, it simplifies video assessment and reduces switching complexity, and it allows operators to focus on limited video feeds. And avoid sensor interference. So basically, if you have ground sensors and you're putting a pole in for a camera, as the wind vibrates the camera, it can disturb your ground sensors. So take that into consideration too. So your SOC, your Security Operations Center, they can be central or virtual command centers. They can be remote, they can be cloud-based. Monitor placement, think ergonomics, think of the comfort of the operator looking not up at an angle, but eye level if you can, if that's possible even. And make sure the operator doesn't tire easily by having a poorly designed ergonomic system. During construction of the SOC, you can share pathways for cabling, and you can also make sure there's room for expansion if needed. And it's always a good idea, if in the event that video is unavailable or ineffective, it's a good idea to have a security officer available to do visual checks. So a security officer complements video assessment. Safety integration and intelligent video. So you should always separate safety versus security. So what that means is, if there's any safety related monitoring going on, that should be separate from security. So you don't want any safety surveillance distracting operators who are looking at security threats. Analytics can be centralized at the VMS server or distributed on the edge, on the camera itself. That is getting very popular because the cameras nowadays have very powerful processors in them, and they're more than capable of doing many tasks to take the load off of the centralized server. And use cases, high-risk transportation, government, retail, people counting. Analytics can count people. based on looking at a room or counting people going in through an entrance and out of an exit. And one thing, I mentioned operator fatigue a little bit, but analytics do help reduce the load on the operator because you can then define what you're trying to catch. You maybe want to try catching cross-line detection at the perimeter. If someone crosses the line from outside to inside, that is something the operator doesn't have to stare at all day. So analytics can help an operator. And they found with studies that operator fatigue is a real thing. And it takes about 20 minutes when you're staring at a bank of monitors for your attention to drop to a dangerous level. So anything you can do to help that out would be important. Legal and privacy. Respect privacy expectations. There should be no cameras in restrooms or locker rooms. If you are using covert cameras, sometimes legally you have at least to put a sign up saying video surveillance in progress. Other times, if you can't see the camera, sometimes people don't even bother putting a sign up. Don't use dummy cameras. They can be very dangerous in that they give you a false sense of security, or a person a false sense of security thinking they're under surveillance and they're safe. They're not. But I have run into some installations of dummy cameras. Audio capture. Now that is a little different. That is something you do have to be mindful of. There are many laws. Each state has its own laws on audio recording. Even in correctional facilities, you have to be careful you don't record audio in some cases because the inmate might incriminate themselves on camera and in audio. So they're very careful about that. So each state has its own regulation, but seek counsel on that. Make sure you're legally prepared. Procedures and documentation. Well, let's go back. So select by sensitivity first, then resolution and format. Evaluate natural lighting. Field demos are best, absolutely. And consider mean time between failure. We spoke about this last week. The total cost of ownership, vendor support, very important. And documents. Is your vendor, whether it's an integrator or a manufacturer, make sure they have very good support and are more than willing to help you out. And maintain complete operations and maintenance and documentation. Acceptance testing. We spoke about this a little last week too. So incoming inspection and burn-in before install. I had some customers who would set all the cameras up in a warehouse and just turn them on and burn them in for a week to make sure nothing failed before installation. Make sure you test night focus and night performance under true lighting conditions. Resolution checks with test targets. Use a 1-foot test target with either letters on it or some sort of grid pattern where you can resolve that with your camera. And verify the alarm to video speed, which should be in a matter of milliseconds. Lighting surveys and nuisance alarms. Exterior grid surveys. So for lighting, that's basically just dividing up your area into a grid pattern, virtually or with a map. And then make sure there's adequate illumination in each of these grids, and they don't change year by year. Interior checks for shadows or blind spots. As I mentioned, maybe things change, maybe a wall goes up, maybe a blind goes down, and it can change your initial assessment. Define acceptable nuisance alarm rates. Remember, we spoke about nuisance alarms and false alarms last week. A nuisance alarm is typically something like moving vegetation or an animal crawling into your field of view. A false alarm is usually equipment malfunction. But define an acceptable limit. 1 per zone per day, for instance, or 2 per zone per day. If you go over that, then start looking into what could be the problem. And investigate recurrences of nuisance alarms. Adjust the design or make sure the sensors are clean and the lensing they can see, whatever they use, is clean too. Maintenance program. Staff should be trained on the operation. Spares, spare cameras, good to have a few on hand just in case you need a quick swap out if it's a critical camera. Logs, a lot of VMSs and cameras themselves can create logs for you. Typically VMS is a very good logging system. It tells you who moved the camera, if it's a PTZ and when. And contingencies, guard posts if video is lost. It's always a good backup plan. Evaluating assessment systems. So minimize time. Sensor alarm to video display should be quick. It should be very fast in the region of milliseconds. Cover the full detection zone, including fence tops. Classify 1 foot target at the far edge under expected lighting, whether it's nighttime or broad daylight. You should be able to see that target and classify it. And 24/7 operation. So make sure you select equipment that maintains its performance in a 24/7 all-weather environment. Recorded versus live quality. Many people have been caught up by the fact the camera can stream 2 different streams, more, but they can stream 1 live stream and 1 recorded stream. Sometimes your live stream will be at 4K resolution, let's say, but your recorded stream is only 1080p or less. So when you go back to review the video, you find why does this look so bad? Make sure your recorder is getting both streams. Sometimes you don't even need a full high resolution live screen, but it's very important to have the best resolution you can get for your recorded stream. Validate storage settings for intended use. Ensure resolution, bitrate, and retention settings meet operational and evidentiary needs. Test the export, playback speed, and document acceptance criteria in contracts. Define and agree on image quality, playback speed, storage performance, and those benchmarks are what you're going to use as your acceptance criteria. Maintenance, why it matters. Uptime is protection, downtime is exposure. Regular testing of cameras, recorders, and displays. Make sure the image quality is always looked at and monitored, and identify problems if you see them. Ensure clear procedures and service agreements are in place to quickly restore functionality. And if needed, update firmware and configurations and log that in a change control. Do not go and update all your firmware at once. If you have 500 cameras, don't broadcast it out using the manufacturer's utility. Do a test first to make sure it works on a single camera, and then you can bring it out to maybe 10 cameras at a time if you're willing to do that. So firmware updates. There used to be an old adage that said that if it ain't broke, don't fix it. But these days with cybersecurity threats, sometimes firmware will give you added protection against cybersecurity threats. And the future of video surveillance. Well, there will be better sensors. Right now, they're getting really, really good. There'll be low light capabilities will improve, dynamic range and resolution. There'll be even better compression and smart codecs and faster networks. We're probably going to go beyond 10 gig networks at some point. Cloud and hybrid storage are improving all the time. Hybrid being partially on premises and partially in the cloud. You may have a backup on your premises. That's getting more affordable, and that may be the future. And analytics and VMS usability keep improving. They do. There's analytics for every case these days. There's even audio analytics for glass break detection, for screen detection, everything. So analytics especially have got a very bright future. So that's it for the video surveillance part. I just wondered if there were any questions. I knew I went through that very fast, and I apologize if I did. And if there's no questions, I will then go on to communications and annunciation system, sometimes called AC&D. So we're going to be looking at systems used to transmit and present alarms. Was there a question? Yeah. So it's basically, we're going to be talking about systems used to transmit and present alarms within physical protection systems.
Yeah, I can pick up the birthday card tomorrow if you want to avoid.
I wonder if PC can mute their, okay. So the system also must be able to move alarm data from sensors to a central display for the operator to interpret. And the goal is rapid, clear communication to operators. Speed and clarity are essential. So let's look at system attributes for an AC&D. It's got to be robust. It has to operate in all environments, summer, winter, no matter what, day, night. It has to have a very good MTBF as specified by the manufacturer. It has to have good redundancy. There should be backup components available. It has to have good security itself. So the housing that it's in, if it's a sensor, should be, or cabling, should be protected from adversaries. It should be in conduit, heavy conduit, and any boxes should be tamper resistant. And really, really important, ease of use. It has to be very intuitive for operators. So the communication subsystem, that will transmit data or transfer data from sensors to display. It requires high reliability and speed. And the data stream can be proprietary, remote, or hybrid. And automation platforms will significantly enhance and speed up the signal flow. Wired communication methods, we've got twisted pair, shielded or unshielded. Shielded typically gives you better resistance to EMI and radio frequency interference. You can use voice grade lines for audio, for intercoms, that sort of thing. There are some systems that use power lines to transmit data, but I don't have a good feeling about those. They do have limited use and they can be susceptible to a lot of EMI. And optical fiber, of course, fiber optic cabling, high capacity, and it's basically immune to electromagnetic or radio frequency interference. Video transmission methods, we mentioned this, coaxial cable, even telephone circuits, well, you wouldn't get very much out of that. Optical fiber and wireless and network connections. Alarm transmission configurations. You can have a loop system where every device is in a closed circuit. It allows signal to travel in both directions. Point to point would be kind of a star-based system where you would have a central point and each connection would be going out to a specific device. And then multiplexing would be a single cable, but multiple signals being multiplexed on that same cable. There's TDM, which is time division multiplex, and FDM, which is frequency division. I don't think there's specific questions on what they are, but I would check with the POA just to be sure. And then wireless systems too. Always good when you can't run a cable, but you got to make sure your security concerns are addressed, interference and the range and everything else too. More in wireless communication, it could be just simple radio, voice and data. It could be cellular using public cellular networks. It could be a private fixed wireless systems. Yes, you can get private cellular systems for your own facility if you want, and it reduces your dependence on the public network. And then you've got satellite-based systems, geostationary, middle Earth, and low Earth orbit satellite options. The impact of building materials on signals. So heavy steel and reinforced concrete blocks or attenuates RF and video, creates dead zones. Other materials, glass with metallic coatings, reduces RF penetration. And the mitigation for that is to use repeaters if you can do that. Sometimes repeaters, you can reroute the wireless around just by pointing the antenna at the repeater. Signal boosters or wired alternatives where necessary. Microwave and laser systems. Microwave is line of sight. It is very high speed and it offers very high capacity data transfer, but it does require an unobstructed line of sight between the antennas. Laser is very secure. It's very hard, if not impossible. Well, nothing's impossible, but it's very hard to intercept. And it is sensitive, unfortunately, to weather and alignment issues. So if the weather degrades, heavy fog, snow, that can degrade the signal. Both need clear paths and specialized equipment. Some communication security options. Underground routing, that's a good protection. Alternate path cellular radio, line supervision, a resistor at the end of the line with a known resistance will tell the system head that there's something broken if the line is broken, and scrambling and encryption for sensitive data. So the control and display system, this is the operator console. It should be centralized workstation, typically in the same station as where the video management system is observed. There should be clear, concise alarm info, location, time, type, and so on. There should be relevant controls only available on the user screen. Don't be cluttering up the screen with all sorts of controls that are never used. Use the most relevant and commonly used only on screen. And the best thing that I can think of is integration with video and maps. If you have a map that shows you a clear path as to what's happening with a sensor, when it trips at a certain point in your fence, in your perimeter fence, it will show you on the map where that trip occurred. Ergonomics and human factors, very important. There should be comfort in the SoC. Temperature should be comfortable, lighting should be adequate, and there should be no noise. Optimal display control and control placement, and keyboards, controls, any joystick controls, they should be readily accessible. The displays themselves, not too much of an up angle if you could. Sometimes there's no choice, but in that case, the operator should move back, and then so he doesn't have to stretch his neck up so far. Audible and visual alerts are definitely important, help you alert the operator. And all of this is to minimize operator fatigue. That's the end goal. GUI design, graphic user interface, what the operator sees. Limit the windows and menu depth. Don't make it overly complex. Only show him the relevant windows that he needs for whatever he's doing. Use consistent icons and colors. Use interactive maps with sensor status. And have an operator first philosophy. Design the interface around the operator's needs. And it should be prioritizing usability over complexity. Video alarm assessment. On the initial alarm, there should be immediate image capture with alarms from the camera. So the camera should be able to start recording or do a still image grab based on that alarm. The components, lighting, transmission, switching, recording, each element must work together for clear video evidence. And resolution based on threat and use. Your resolution of your camera, if you want, has to match your security needs. So last slide on this, it's getting late. Yep, I think we still have time for some questions, Nelson, though, which is good. Okay, trends in AC&D integration. Big data, analytics, artificial intelligence, all of those are coming online to make the operator's job easy. Never to replace the operator. You still need human intelligence in my mind, but to assist the operator as much as possible. Cloud and managed services are definitely coming online, not just for video, but also for alarm system management. NFC and smart cards are coming online for access control and product hybridization and robotics. Multiple functions into a single device. And there's some quite good robotic solutions out there. I've seen quite a few at the trade shows that have their own cameras on board, and they can be sent out to do video verification sometimes too, just to see what's going on. And it can be kind of a deterrent because there's cameras on board these robots too. So that's it for the entire presentation tonight, except for the practice test. So I just wondered if there's, I know it was a while ago since I started, but if there's any questions you have on what we discussed, I'd be more than willing, and Nelson and I'd be more than willing to help out if we can. And if not, Nelson, we can go on to the questions, I guess.
Yeah, I'm sure that some of the people have many questions because it's a lot of information. But yeah, we can
I
go into
know,
the questions, and
right?
they at the end you will have that information. You can go over that information anytime that you want, and also the questions. If we cannot go to all the questions today, next week those questions will be in the website, and you can go take the quiz in your own piece and rewatch the video, okay? Or read the information. The information in the website at this moment maybe is not complete, but I will include all these, not the slides, but the information that is included in the slide, including the keynotes on the website. You will have like a summary of the POE book. It's not a POE book, and I recommend to have the POE book and all the document from ASIS, but the website will be a summary of that. Okay,
Yep.
let's go in the questions.
Okay. So let's start with question one. We're going back to AC&D here. Which of the following attributes is considered the most critical measure of an alarm communication and display system's overall effectiveness?
You can answer the question in the chat.
Yep, and I'll give you a few minutes to do that. Okay, we'll just go ahead and give us the answer. Quite tricky. I mean, A sounds reasonable. The correct answer is B. How well it quickly and clearly communicates alarm data from sensors to the system operator. That is the whole point. And there's a quote from the POE in the bottom there. Our old pixels per foot. A security system is being designed to identify individuals from a distance reliably. According to the source, what is the minimum required resolution for subject identification? Remember, there was face recognition as well as subject identification. And again, you can answer in the chat if you'd like.
And like Alan say, this is the POA information. Every vendor, it could give you a different number, and but then that is the information is in the POA book.
Yep.
It's similar. All of them is similar. It's not exactly the same, but it's similar.
Yeah, it is pretty much the same. Typically 80 pixels per foot for face recognition. Some people say 70 is pretty close, but the answer here is 46 pixels per foot. And remember, that is for subject identification. Facial recognition is 70 pixels per foot. And there's the POA quote at the bottom. According to the provided sources, which of the following are categorized as the three main types of lenses by adjustability and flexibility for a video surveillance system? Remember, we mentioned that as the three types. Which of the following is not? Remember that NOT there, important. Not explicitly mentioned as a future improvement for video surveillance systems. This was the last slide we did in video surveillance. And the answer is decreased reliance on network infrastructure. That is definitely not, won't be a future improvement. There's going to be increased reliance on network infrastructure. Next up, which of the following represents a key area of improvement expected in future video surveillance systems, according to the sources? Based on the same slide. And I'll just bring that up. The answer, of course, is B. I hope it's not C, because I don't want to go back to analog video transmission. What is considered no perceptible delay for a human operator when alarms are reported? Ah, this is a tricky one. So the answer to that is a few tenths of a second. And I hope I didn't confuse anyone by, I did mention milliseconds several times, but a few tenths of a second could still be milliseconds, I suppose. But that is the correct answer, a few tenths of a second. Now, notice nothing precise there. And no perceptible delay is a few tenths of a second. Intelligent video systems are noted to be increasingly proactive tools in security. Which of the following best describes their enhanced capability? The answer there is automatically detecting and deterring undesirable activities, notifying security personnel proactively and assisting in automating responses. And there's a quote from the POA. Which of the following is a key advantage of optical fiber over conventional metal wire for security communications? We mentioned this a couple of times. By the way, Nelson, I'm finding these questions very typical of what you might expect. So these are good questions.
Yeah, I'm trying. The first section were not good, but I will replace those one from the first domain for a more tricky or more critical thinking questions.
Yeah. So as we discussed a couple of times, less susceptible to EMI or RF interference, or EM, electromagnetic or radio frequency interference. What essential elements are encompassed within the recording equipment component of a video surveillance system? This one should be fairly easy. And by the way, when I did my PSP, it was a long time ago. I did find that answering sample questions like this was a very good learning tool, because if I wasn't sure of the answer that I came up with, I would go back and find out why I was wrong. And I find it's a good learning tool. So the answer here is recorders, equipment for image selection, recording speed, capture resolution, and compression format, as the POA mentions. What is the primary security function that video surveillance systems fulfill, with all other functions serving as enhancements? This one's a tough one. Remember, primary security function, I think that was the first slide we looked at. The answer is deterrence, detection, and advanced enhancements. That is straight from the POA. When comparing multiplexing and point-to-point alarm transmission systems, a critical security vulnerability of a multiplex system is that. Remember what the multiplex system was it was a single wire carrying multiple data sets. So with that in mind, the correct answer is A, because those multiple data sets on that line, if the communication link is broken, then all of those individual multiplex data sets are lost. When a digital cellular transmission is intercepted, what is its immediate state? I don't think we covered this, but it's a good question. Although, maybe think of at least one of the slides. So with a process of elimination, a C doesn't look possible. It's not transmitted in the clear. It requires only basic frequency inversion to be understood. That is not true. It could be either one of these, but basically when you intercept a cellular transmission, it's just a string of binary digits. That's not immediately intelligible. According to ergonomic principles for AC&D console design, where should the most important indications on operator inputs be placed? Again, this one has two good possibilities, though. But the answer is B.
Mhm.
We didn't really mention the secondary area, and I don't think there is such a thing, but in the primary interface area within a 30-degree viewing cone. Why is resolution a critical consideration when designing a video surveillance system, especially for security applications? The answer is C. And the POA is still talking about the number of horizontal scan lines, which is pretty amazing. Or digital pixel arrays.
Yeah, they are still talking about horizontal scan lines. That it was the analog word.
Yes, and it's still in there. And this is the newest version, right? This was 2000,
Yeah,
what,
this
2020 or
2021 is the last
Yeah.
version. Yeah, 2021.
Right. And even then, CCTV, analog CCTV was basically dead. But
Yeah.
okay, but it is what it is. For video signals transmitted via coaxial cable, what is the typical maximum distance without further processing between the camera and a monitor if a clear signal is desired? I kind of touched on this when we spoke about using conversion boxes or encoders and decoders each end to travel, so TCP/IP can travel. But again, this is the POA, and I'll give you the answer. It's actually 1,000 feet.
Yeah, and I will not worry about that. I think that the most common question will be keep in mind the 100 meter, that is 305 feet is the most common. And nowadays you can get cable or Cat6 cable, Cat6A cable that you can run more than 305 feet of cable, but the rule is at 300 feet.
Yep. Yeah, you're right. There is specialized cable. And I believe it works quite well too. It's a special manufacturer who does it. I can't remember off the top of my head.
Yeah.
Okay. Why is proper attention to privacy a significant consideration when implementing video surveillance systems? And I think we mentioned this. And the answer there is D. Generally inappropriate to place cameras in areas with a reasonable expectation of privacy to avoid liabilities. While measuring operator response time is difficult, what specific aspect of an AC&D system is considered a direct measure of its effectiveness? I think we did mention this. And the answer is, of course, the speed at which it processes and displays information. What's a key characteristic of megapixel cameras and video surveillance systems, and how do they generally compare to analog cameras in terms of resolution? I think we mentioned this too.
Yeah.
And as I mentioned, with analog, of course, you're limited in resolution to the video system, whether it's NTSC or whatever, it was 720 lines, I think, or 720 horizontal pixels. Yeah, but with the megapixel, of course, we can now go several tens of megapixels, 20 megapixel cameras, 24 now, getting more common for crowd surveillance, that sort of thing. What are the two critical elements of an alarm communication and display system? From my experience, anytime I see cost effectiveness in a PSP question set, it's usually the wrong answer, because I don't think we mentioned too much about cost effectiveness. It's more about a reliable working solution.
Mm.
And the answer there is transportation, communication of data, and presentation, display of data to human operator. What is the recommended design philosophy for a video surveillance system? I think I mentioned this 3 times. This is a question you might see. So just remember, don't let a vendor come in and sell you equipment or the application. The application should dictate the choice of equipment. For high security or complex alarm communication systems, what is required to handle hardware failures and ensure message delivery? And this is a hard one. Answer is A, redundant hardware with automatic message routing. And there's the POA quote below. For video surveillance systems requiring transmission over distances of 1,000 foot or more, what is often considered the best choice for the transport medium? Pretty easy one. Fiber optic cable, really good solution. Can be expensive, but it's a very reliable way to go. What is a fundamental security consideration for any unscrambled or unencrypted wireless communication? So any unscrambled or unencrypted wireless communication, it's considered available for interception. Anyone can receive it with the right equipment. How do video analytics primarily contribute to risk mitigation in a video surveillance system? And I hope it's not C, but the answer is B. By proactively notifying personal events, thus enabling a more proactive detection and prevention approach. Time is 2 minutes. Time for maybe a couple more questions.
Yeah, we can
What is the
Go ahead.
Oh. Yeah, okay, we can do it. What is the primary purpose of line supervision in a wired alarm system? Do you remember questions on line supervision? But remember, we had that resistor value at the end of the line that was a known resistance, and if it changes, then you know there's a fault in that line or it's been broken. The transition from analog CCTV to modern video surveillance systems is primarily characterized by. And that's a good one. It's a shift from closed circuit limited displays to digital scalable network-based systems. And that's the thing, closed circuit back in the day, it was kind of a one campus solution, right? It was very difficult to share that with outside of that campus or have remote access to it. Okay, one more question. When designing graphical user interfaces, GUIs for ACMD systems, what is a crucial guideline regarding the use of color? All right, well, the answer here is the color should be used sparingly, and users should not have to depend on it to operate the system. Part of the concern there, of course, is color blindness. In case someone has it, 10% of the population has some degree of color blindness. So it's not a good way to have a primary system. I'll do one more because it involves our favorite subject, pixel density. What is the specified pixel density per foot required for a video surveillance system to achieve facial recognition capability? And the answer is, of course, 88. That's the most we can expect for facial recognition, or the least we should expect for facial recognition. So, Nelson, I think that I can stop there if you like.
Yes, we can stop here. You will have in this section, we have 40 questions. We went into the 28 question. You will have 12 more in the website. Oh, you will have all of them in the website, and you can take the quiz again if you want. Okay. But yeah, we can stop here, and thank you everybody to be here and stay with us until the end. It was a lot of information, but yep. It's what it is.
Yeah, it is definitely a lot of data, a lot of detail.
Yeah, feel free to go. I will enhance the information that is in the website right now with this information that we present today. And feel free to go there and double check or review, study, use as a study guide. Okay. Thank you, guys. See you next week.
Yep. Thanks, everyone. Have a good night.